The following is an explanation of example 5.8 out of the textbook, located on page 200. We're given a sample of methane gas with a volume of 3.8 liters at 5 degrees Celsius. This sample is then heated to 86 degrees Celsius at a constant pressure. We are then instructed to calculate the volume. I'm going to start out by writing my ideal gas law. PV equals nRT. I'm going to go through with my highlighter and highlight the things that are changing. I have a volume that is changing, and I have a temperature that is changing. Everything else remains constant. So the pressure, the number of moles, and R all remain constant. As such, I'm going to go ahead and take my equation and move all of the blue stuff to the left and all of the pink stuff to the right. I do that with a simple little bit of algebra. nRT, or nR over P equals V over T. What this means is that no matter when I look at this sample of methane, it's the same number of moles at the same pressure. So no matter what the volume is, I can figure out the temperature, and no matter what the temperature is, I can figure out the volume. We have initial time and a final time. Initially, I have a volume of 3.8 liters and a temperature equal to, well, I don't really like 5 degrees Celsius. I'm going to add 273, and I'm going to get 278 Kelvin. At the end, I have some unknown volume, as well as a new temperature. Again, I don't like Celsius, so I'm going to add 273, and I get a temperature equal to 359 Kelvin. Once this has been done, I can set up PV equals nRT for both times. Only I'm going to use the version that I derived up above, where V over T equals nR over P. And because the question tells me that the N and the P are the same on both sides, as well as the R is always the same on both sides, taking a number that doesn't change times another number that doesn't change divided by another number that doesn't change, this whole value remains the same. Therefore, my V initial divided by T initial, excuse me while I scroll down a little bit. Nope. While I scroll down a little bit, there we go, equals my V final over T final. I can just go right ahead and start plugging in my numbers, and I get 3.8 over 278 equals V final over 359. Multiply both sides by 359. Those will cancel. I'll get a final volume equal to 4.9 liters. As with all changing state questions, we have two variables that remain constant, our N and our P, and two variables that are changing. Now, the question does not explicitly state that our number of moles is changing. However, it does tell us that we're dealing with a sample, A being singular. So that's an implied statement that our number of moles does not change. Again, this is example 5.8 off of page 200.